We are starting with this idea of the mole. Has anybody heard of it before? You would have, yes. Leroy, have you guys had any discussion of the mole at all? No? Not like, what is it, that movie? The Austin Powers with the guy, mole, mole, mole. Yeah, no, not that. So this is usually a concept that only comes up in a true chemistry class. And the mole is a way of counting, or rather maybe calculating, the number of atoms in a substance. That's a very general version. So a little background. We have to look at how the amount of matter can be measured. So it can be measured in three ways. We can take the mass of a substance. We can take the volume. And we can actually just count the number of particles. All three of these ways give us the amount of a substance, of matter, but in terms of three different things. Okay? So the mass gives us how much of it there is. The volume tells us how much space it takes up. And then the number of particles tells us just that, the number of particles. When we talk about the mole, it's abbreviated with lowercase mol. This is the amount of a substance that contains 6.02 times 10 to the positive 23rd representative particles of a substance. So this number is a non-negotiable commit to memory. It'll probably just happen automatically, because you'll be working with it so much that it happens. You'll learn that number without even trying. When I talk about representative particles, that means that we can change the unit to this number as we need to. If we need to figure out how many molecules, the unit for this number can be molecules. If we need to figure out how many atoms, we can change this unit to atoms. It's kind of got this revolving door for whatever unit we need it to be, which is nice, but it also gets to be a tad bit confusing. So this is the SI unit for the amount of a substance. So for example, 6.02 times 10 to the 23rd water molecules is equal to 1 mole of water. Okay. Avogadro's number is this number. Okay? He's the dude that figured out that the number of representative particles in a mole is 6.02 times 10 to the 23rd. A representative particle is the smallest unit in which a substance naturally exists. So pure elements, so like sulfur or nitrogen, their representative particle is an atom. An atom is the smallest part of an element that still maintains that element's property. A diatomic element, so that would be like H2, their representative unit is a molecule. Ionic compounds' representative units are formula units. Molecular compounds, these are the ones with the covalent bonds, are molecules. All right, so let's put this into practice. The element carbon consists of two primary forms, graphite and diamonds. How many moles of carbon atoms are in a sample containing 4.72 times 10 to the 24 atoms of carbon? So this goes back to, was it maybe chapter 4, where we were doing unit conversions? So the unit conversion here is going from atoms of carbon, and we want to turn that into moles of carbon. So to do that, the first step is the same as when we were converting inches to centimeters. You write what you were given in the first box. So 4.72 times 10 to the 24th. This is, remember, important to make sure you label your units. Atoms of carbon. So we need atoms of carbon to cancel. So we put that on the bottom. And we want to convert that into moles of carbon. So from the previous slide, we can say that 1 mole of carbon is the same as Avogadro's number, 6.02 times 10 to the 23 atoms of carbon. So we needed atoms of carbon to be the unit. And so remember, we can change the unit on Avogadro's number to be something that we need it to be. So doing that allows this atoms of carbon to cancel. We're left with moles of carbon, which is what we want per the question. And so now we can set up the arithmetic. You multiply across 4.72 times 10 to the 24th times 1, and then divide by what's on the denominator, 6.02 times 10 to the 23rd. It is imperative that you watch your parentheses. You need to separate your numerator and your denominator by parentheses, or you will get the incorrect answer. So let's practice this right now. If you have your calculators, please throw it in. And if we're getting the wrong answers, we can individually fix this. So first of all, what did we get here for an answer? How many moles of carbon do we have? 7.84. Let's try to carry our answers to 2 decimal places, please. So that is correct, 7.84 moles of carbon. Taking it a slight bit more complex type of problem is a certain quantity of sulfuric acid contains 4.89 times 10 to the 25th atoms of oxygen. How many moles of sulfuric acid are in that sample? So what bit of information are we given? Cora?
4.89 times 10 to the 25th atoms of oxygen.
Very good. Times 10 to the 25th atoms of oxygen. Remember, that's what we start with. So what unit needs to be placed on the bottom? Yep, atoms of oxygen. And then what unit should go on the top? What? Okay, not quite. This one we can't go directly till mole because we are currently working with what compound or element? What is the element or compound that is written in the train tracks right now? Sulfuric acid. So not only do we have to change our unit of measure, we have to also change to the correct compound because this compound is asking for how many moles of sulfuric acid. Okay, so we need to get into sulfuric acid. So our unit up here needs to be something dealing with sulfuric acid. And so what is the relationship of oxygen atoms to sulfuric acid? So looking at H2SO4, there's a relationship between oxygen and the sulfuric acid as a whole. What would be the relationship? Okay, so we know the number of oxygen atoms in sulfuric acid is 4, so we can fill that in. And how many oxygen atoms are in that sulfuric acid? Or reverse. So there's 4 oxygen atoms in how many sulfuric acids? 1. Now, what is that 1? We've changed to the sulfuric acid, which we need to, but now we need to change the unit. So, if I were to say there are 4 oxygen atoms in 1 blank of sulfuric acid, what is the blank? Good, 1 molecule. QO. I feel like we probably have some questions about that.
How do we get 4 atoms of oxygen?
So then next, we're in sulfuric acid, which is good, but we're in molecules of sulfuric acid. And we want to be in moles of sulfuric acid. So what is the relationship between the molecules of H2SO4 to the moles of H2SO4? The number relationship. What's the new concept going right here, guys?
So I need the 6 point.
Yeah, we need the 6.02 times 10 to the 23rd. But now does that go with the moles or with the molecules? The molecules, good. So this will be 6.02 times 10 to the 23rd to 1 mole. So we can check that our units cancel out. We have an atoms of oxygen, and then atoms of oxygen will cancel. Your molecules of sulfuric acid with this molecules of sulfuric acid, and we are left with moles of sulfuric acid, which is what we want. And so now we do the arithmetic. Multiply across the top, 4.89 times 10 to the 25th. Do we need all of these ones to multiply? Nope. So then divide it by 4 times 6.02 times 10 to the 23rd. Putting that in your calculator should look like 4.89 times 10 to the 25th divided by 2 parentheses, 4, close parentheses, open, 6.02 times 10 to the 23rd, close, close. These outside ones are just to separate your denominator from your numerator. So going through this arithmetic, what do we get for our moles of H2SO4? Cora?
20.31.
Very good, 20.31. Again, instead of doing sig figs on these, please just give me 2 decimals. The last concept, 20.31. The last concept for today is molar mass. And this is the mass of 1 mole of a substance. Generally speaking, we take the molar mass of a compound, but you can do it of a single element. In order to calculate your molar mass, you need the atomic mass of each element in a compound. The atomic masses are found on the periodic table, and the unit is the atomic mass unit. We abbreviate that as AMU. Another definition of the mole is the amount of a substance that contains as many representative particles as the number of atoms in exactly 12 grams of carbon-12. That is the basis for being able to do these molar calculations. The atomic mass of an element will be expressed in grams, is the mass of 1 mole in that element. So your molar mass will have a unit of grams over moles. Your molar mass is the mass of 1 mole of the representative particles in a substance. And the formula mass is the sum of the masses of all the atoms represented in the chemical formula. This is a lot of words for a very simple concept. So, putting this into practice, we need to calculate the molar mass of calcium nitrate. So, in order to do this, you need the chemical formula and we need periodic tables. So, we have one hanging in the room. Do you guys still have one of the periodic tables that I've sent over multiple times? Okay. So, to do this, we look at calcium and NO3(2). So, how many atoms of calcium are in this particular compound? 1. Then you look at the periodic table and tell me the atomic mass of calcium. Atomic mass. Yeah, 40.08. Each periodic table might round a tad bit differently, and that's okay. So just make sure you're using all of the digits given to you on the periodic table that you're using, okay? How many nitrogen? So this is calcium. Nitrogen. How many nitrogen atoms are there? 2. Remember this 2 down here gets distributed. So there are 2. Then you look at the mass for nitrogen of a single nitrogen atom, not the double. Kenzie? 14.01. Oops, sorry. Then, again, you do the same thing, but this time we're looking at oxygen. How many oxygen atoms do we have in this compound? 6. Multiply that by its atomic mass, and we get, pardon? 16.00. So then, once you have all of that sorted out, you do the multiplication for each of these. I'll do this first one. Somebody have the nitrogen figured out? 28.02. And lastly, the oxygen. Louder. 96.00. Then your last step is add all of them together. 0, 0. Oops, that's a 1, isn't it? Uh, 14. 164.1. Okay. And then you put the unit on it, AMU, or if you're feeling fancy, you can write grams per mole. It will become very beneficial for you to know that AMU and grams per mole are interchangeable. Okay?